So in this case, what we're dealing with is a relative atomic mass question in relation to a sample of iodine. And this particular one is a case of 3 isotopes in the sample. In order to work out the relative atomic mass in this case, and as it says in the question, we have to work it out to 2 decimal places. We're going to have to look at, okay, well, what are the relative isotopic masses and what are the percentage abundances? All this information is given in the question, so this should be quite straightforward. So if we start off with putting together the calculations, so we need to add the relative isotopic masses with the respective percentage abundances. So let's do that first. So that's going to be 125 multiplied by 14.36, and of course we have to sum these, so it's going to be then 126. So this is the 126 here multiplied by 66.43, and then we have the 127, and that's multiplied by 19.21. So, and all of this has to be divided by the sum of the percentage abundances. But before we do that, I'm actually just going to work out what the answer of this is. So if you get a calculator and have a go of working out what that is, what you should come to is 126, 04.85. So that's 12604.85. Now we would then divide it by the sum of the percentage abundances, and what we're not going to do is just assume that it's 100, right? Because it might not be. So we're going to add up the percentage abundances first. 14.36 plus 66.43, and I would encourage you to try and do this calculation yourself to kind of satisfy yourself that actually, yes, this adds up to 100. So I mean, that is what we're going to come to, but as I said, sometimes it might not actually be 100. You have to check, and so that's going to be, if you work it out on a calculator, that will come to 100%. And what that tells us is that this is the number we need to divide this by. So that's going to be divided by 100. Divided by 100. And so if we do that calculation, of course, what we're going to get then is 126, right? 0.0485, right? Now, is this our answer? What does the question ask us for? It asks us to calculate the relative atomic mass of this iodine sample, and we can see, if we just, by way of comparison, compare this with the numbers we've been given, we can see it does fall somewhere between these numbers. It does fall somewhere between 125 and 127. I mean, on inspection, it does look roughly where you might expect it to be. However, the question does ask that our answer should be given to 2 decimal places if it does have decimals. And in this case, it does have decimals. So this is not quite our answer yet. So what we need to do is round this to 2 decimal places. 126.05. So that would be now our actual answer, 126.05. And so that is, in this particular case, the relative atomic mass. Okay, so yeah.